Hello, everybody. Welcome back to Mathlete's Corner. And guess what? The 2025 AMC8 is right around the corner. So today, we will be looking at the first 5 problems from the 2024 AMC8. This is the first video of a 5-video series. Each video will cover 5 problems from this test. So let's get right into the first question. So the first question says, what is the ones digit of this expression here? So first, let's change those minus signs to plus signs, and we can factor out a big -1. And finally, plus 2. Now, the ones digit of this is 2, and the ones digit of this here is the sum of the ones digits of all of these numbers. So there's 5 numbers. Each of them has a ones digit of 2. So that gives a total of 10, which has a ones digit of 0. And when you subtract 0 from 2, you get B, 2. So let's keep it moving. What is the value of this expression in decimal form? So this question is just a quick evaluation of exactly what we're given. So 44 over 11, we know that's just equal to 4, plus 110 over 44. So we can cancel 11 from both of them. And then we can also cancel 2 from both of them. So it's 4 plus 5 over 2 plus, and we want to add 44 over 1100, so we'll cancel 11 from the numerator and the denominator. And now we're left with 1 over 25, because 4 over 100 simplifies to 1 over 25. Now, we want it in decimal form, so let's just go ahead and simplify it into decimal form. And 1 over 25 probably shouldn't have simplified it. It's 4 over 100, so plus 0.04 is equal to 6.54. And that's C. Now, problem 3. 4 squares of side lengths 4, 7, 9, and 10 are arranged in increasing size order so that their left edges and bottom edges align. The squares alternate in color white, gray, respectively, as shown in the figure. What is the area of the visible gray region in square units? So let's zoom into this diagram. So we see that we want this total gray region here. And as it's given, it's 2 different regions. So let's go ahead and add them separately instead of considering the region as one quantity. So let's zoom out again. All right, so how do we find this outer region? Well, the better question to ask there is, how do we get that region? Well, we take a square of side length 10 and we remove a square of side length 9 to get the region here. So we take the area of the big square of side length 10 and we subtract 9 squared, and that is equal to 100 minus 81, which is 19. So that's the area of the outer gray region. Now, for the inner gray region, we can just repeat what we just did, which is an important idea throughout the AMC8 and all the AMC contests. So now for the inside gray region, we can do the same thing. 7 squared minus 4 squared. That's equal to 49 minus 16, which is 33. Now we can just add them up to get a final answer of 52. Now, question 4. When Yunji added all the integers from 1 to 9, she mistakenly left out a number. Her sum turned out to be a square number. What number did Yunji leave out? So, for this question, we have an unknown. That unknown is the number that she mistakenly left out. So let's call that number x. X is the number that's left out. All right. So what would the sum come out to be? Well, it'll be the sum of all the numbers from 1 to 9 except for x. So let's simplify this sum from 1 to 9 that we have here. And from the formula of the sum of the first n positive integers, we know that this is just equal to 9 times 10 over 2, which is equal to 45. Now, that means that this original expression we had is just equal to 45 minus x. We'll look at the question for information that we haven't used yet, and that here would be that her sum is a square number. So, how can we make this a square number? Well, remember that x has to be in the range from 1 to 9. So the only way that 45 minus x could be a square number is if it's equal to 36, which makes x equal to 9, which is option E. Now, on to the last problem for this video. There we go. Aliyah rolls 2 standard 6-sided dice. She notices that the product of the 2 numbers rolled is a multiple of 6. Which of the following integers cannot be the sum of the 2 numbers? So, the interesting condition in this problem is that she notices the product of the 2 numbers is a multiple of 6. So, let's think about how we can roll 2 6-sided dice and get a product which is a multiple of 6. Well, the most obvious way is if one of the numbers we rolled is 6. So we can roll 6 and 1, 6 and 2, 6 and 3. And right here, we've actually knocked out 3 options because here the sum of the numbers is 7. Here the sum of the numbers is 8. Here the sum of the numbers is 9. So we can eliminate those options. Now we're left with options A and B, 5 and 6. So let's try to show that one of those is possible. So other than rolling a 6, how else do we make a multiple of 6? Well, we're going to need a factor of 2 and a factor of 3. So let's try those numbers, 2 and 3. And we see that those add up to 5. We can eliminate 5. And if you're in the test, you can just shade in B and move on. But for the sake of being rigorous, let's just show that 6 cannot be the sum of the 2 numbers. So let's box out an area here. So how can the sum of the numbers be 6? It could be 1 and 5, 2 and 4, 3 and 3, or it can be the reverse of these, which would end up giving the same product. So here the product is 5, which is not a multiple of 6. Here the product is 8, which is not a multiple of 6. And here the product is 9, which is also not a multiple of 6. And that confirms our answer that 6 cannot be the sum of the 2 numbers rolled. That's it for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next time here at Mathlete's Corner.